All right, I'm going to do these problems on this vector worksheet 1. So determine the x and y components of each of the following vectors. So A, B, C, and D. And I have, for each one of these, it says the magnitude and the direction. So you should have your notes handy. If you don't have these notes done yet, you need to go back and make these notes. And you actually need to take notes, have all this written down. No joke, you're like students who are going to go to college and stuff, so you got to have the notes. There's the notes that I made. And if we're taking things that have magnitude and a direction and we're breaking them up, that means I have this and I want these, right? So I just need to do this r cosine theta, r sine theta. And we're going to pay attention to what quadrants things are in. So for number 1, vector A, make the x and the y components, and make a little chart like that. So, and I guess if we say like the x is negative, whatever, then I don't have to worry about that. I can pay attention to what quadrant. So right off the bat for vector A, that's in quadrant 2, so it's going to be negative positive, right? Negative x, positive y. All right, so to find the x and y components, make sure your calculator is in degree mode. I'm going to go ahead and do 7.5 times the cosine of 35. And then I'm going to do 7.5 times the sine of 35. And that gives me my x and my y for that one. So they are 6 point, let's keep 2 decimal places. Whatever you choose, just be consistent. 4.30. I'd be fine with 6.1 and 4.3 there. And this x was negative, and that's positive because we're in the second quadrant. For B, got magnitude's 24, angles 70. So magnitude is 24, angle is 70. Doing that with a cosine is going to give me my x component, and doing it with the sine is going to give me my y component. And I'm in the third quadrant, so they are both negative. That's negative 8.21 and negative 22.55. C is in the first quadrant, so both positive. And it's a 45-degree angle, so both the x and the y are going to be the same. I'll do them both just in case you didn't catch that. So 14 sine 45 should be the same, right? So let's see, that's going to be 9.90, both positive. And then D is in the fourth quadrant, it's positive, negative, and we got magnitude 10, angle is 20. .40 and 3.42. 9.40, 3.42, and we got positive, negative, fourth quadrant. All right, that's how you do that. So that's way less work than what we did in that example in the notes. Given the following x and y components of vectors, there's the x and the y. That's what those little subscripts. So this is the x, this is the y. Determine the magnitude and direction of the vectors. Okay, and they want us to make a sketch. Sure. And does it say find the angle? Yeah, magnitude and direction. All right, so let's go ahead and sketch them first. So F is 6 and negative 4.5. 6, negative 4.5. So it's going to be something like that. All right? You want to find this is the F right here. find the magnitude and the direction. Look, when you do your Pythagorean theorem, when you do the square root of x squared plus y squared, you can include the negative sign there if you want, but that is just a sign mistake waiting to happen, because if you do this, if you do plus negative 4.5 squared, you are going to get the wrong answer. That is not right, and you know that's not right. If you're trying to find the hypotenuse of a triangle where the legs are 6 and 4.5, it can't be shorter than those. So here's my recommendation to you. Don't include the negative sign ever, because you're squaring both of them, so I mean negative signs are going to go away, right? So if you insist on including the negative sign, then you need to put your numbers that you're squaring, and I mean to be consistent you should probably do it with all the numbers, plus negative 4.5 squared. You want to do that? Type in all those parentheses, knock yourself out, and you get the right answer. But my recommendation is just cast away any negative signs and go from there. So the magnitude of this is equal to, I'm going to show my work. Good boy. Is 7.5. The direction is tangent inverse. Same thing with the negative signs. I'm going to do tangent inverse y over x, ignoring the negative signs. And then I am going to decide what quadrant it's in, because I'm the man. And you're the man, or the woman. And you are in charge here. So don't let, the problem with the tangent inverse is it's always going to give you an angle between negative 90 and 90. And, you know, it could be in the third or the second or third quadrant. So we need to be in charge here and do tangent inverse, y over x, no negative signs. I mean, that's what you've been waiting for all your life, right? For somebody to come along and say, oh yeah, don't worry about the negative signs, just throw them away. So this is it. It's your chance. So 36.9 degrees. Now what quadrant are we in? Well, we had positive, negative, so that's quadrant 4. Just kidding. Positive, negative. So there's your magnitude, there's your direction. Now that was the F, so now it was part A. Part B, I got negative 12, negative 3. Negative 12, negative 3. So it looks something like this. This is the so-called R vector. Should be putting those little hats on them, I suppose. So go a little faster now. Magnitude is the square root of 12 squared plus 3 squared. What am I keeping here? Just to the nearest tenth. How about that? So 12.4. And the direction, you can call it direction or you call it theta. I don't care which. Tangent inverse y over x. That's 3 over 12. About 14.0 degrees. What quadrant are we in? We are in the third quadrant because both the x and the y were negative. Part C, negative 350, positive 145. So somewhere over there in quadrant 2. Magnitude is the square root of 350 squared plus 145 squared, and that's 379, let's say. And the direction, I didn't show my work, sorry. That's the square root of 350 squared plus 145 squared. I think that's important to write that down. Because what if you mess up? Then how, somebody's looking at a number, you have no idea what you did. And that's sad. 145 over 350 is about 22.5 degrees. And what quadrant are we in? We're over here in quadrant 2. All right. This isn't so hard. Suppose vectors R and S have the following components. So here's the x and the y of the R vector, and here's the x and the y of the S vector. Determine the magnitude and direction of vector t, which is the sum of them. Okay, now we're getting more like the example of the notes, except for these ones are already broken up into the x and the y for you. So here's the R vector, here's the S vector, and here's the x part, and here's the y part. So the R vector is -30, -50. And the S vector is -20, +80. And then the T vector, which is the sum of them, is -50 and 30. So that's the answer in like XY form with the components, but they want us to do magnitude and direction. So if I have the X and the Y, and I want the R and the theta, that's the magnitude and the direction, then I need to do this. And we were just doing that, weren't we? So I just need to do magnitude is square root of 50 squared plus 30 squared, and the direction is tangent inverse y over x. So let's call it 58. And then tangent inverse, 30 over 50 is about 31 degrees. Alrighty. Oh, what quadrant are we in? Always want to put that quadrant. Negative, positive. So negative x, positive y. That is quadrant the second. Number 4. After walking 11 kilometers due north from camp, a hiker then walks 15 kilometers due east. North, south, east, west. So they go north, and then they go due east. Is it 11 and 15? 11 kilometers, 15 kilometers. What's the total distance walked by the hiker? What's the magnitude and direction of the net displacement vector from the starting point? So the displacement vector is what you get. Like, that's just where are they from where they started. That's this. But they walked 26. So the total distance, I mean, you're not going to be able to convince this hiker that they didn't just walk 26 kilometers, even if they're not that far from where they started. So the total distance that they walked is 26, and the magnitude and direction of the net displacement. Now so that's the magnitude and direction of this. I'll come back to what I was about to say in a second. Oops, I'm going to clear that. So, same game, just cast in a real context here. So the magnitude of the displacement is 18.6 kilometers, right? That's the length of this. That's how far they are from their camp. And the direction is, I always liked, this is what I was going to say before when I interrupted myself. I always like to do y over x, and then that's the angle measured from horizontal. Right? That's going to be this angle. I'm going to do the tangent inverse of y over x. Tangent inverse of 11 over 15. That's 36.3 degrees. 0.3 degrees. I'm not going to fuss at you if you say just quadrant 1. I'm actually going to say, since this is east and this is north, this is 36.3 degrees to the north, moving toward the north of east. But you say quadrant 1, that's fine. What you can't do is you can't start using north, south, east, west in problems where it's not like a map problem, because can't. Doesn't make sense. All right, one more for this video for the first half of this sheet. So vector A, vector B, and then we want to add them together. So I think I said in the notes that 5 was the first one that was like what I did, and I think that I spoke the truth. So vector A, let's see, we're going to want to break these into their x and y components. So what do we have for vector A? It's 160 at 30 degrees north of west. What the heck does that mean? So 30 degrees, this is, right, if you're looking at a north, south, east, west problem, then north of west is here. That's quadrant 2. So that is going to be, in quadrant 2, we are negative, positive. And I know you don't need to put a plus sign in front of a number that's positive, but maybe for this, it's not a bad idea to just force yourself to put a sign on things. Make sure you're paying attention. So 160 and then 30, so I need to do 160 times the cosine of 30 and 160 times the sine of 30. And that gives me my two pieces there, right? That's back to here. I have the r and the theta, and I need to break it up into those x and y. All right, so 138.6 and 80. Okay, how about vector B? Oh, could you see any of that? Here we go. Let me just stop there for a second. Sorry, I think that was off the page. Just going to chill there. You could pause if you need to write anything down. You can go ahead and pause on that screen there. All right, so sorry about that. B is 220 at 60 degrees north of east. Here's east, north of east is this way, so that's quadrant 1, which means they're going to be both positive. Okay, so what's the 220 and 60? So 220, 60, 220, 60. Why am I doing cosine first? Because that gives me the x. So I'd rather do them in that order. 110 and 190.5. And they want me to add these up to get vector C. All right. And my totals then, this would be negative 28.6, and this would be positive 270.5. And although that's like a version of the answer with the x and the y parts, we have been asked to find the magnitude and the direction. So the magnitude is the square root of 28.6 squared plus 270.5 squared. And the direction is the tangent inverse of y over x. Don't care about any of the negative signs. Just stay positive. And so let's see, 28.6 squared plus 270.5 squared gives me about 272. And do we have units on this? I don't remember. What's going on here? Nope. If these were meters or whatever, we just everything would have the same units. Nothing hard going on with units. Just if we have any, we want to be respectful of that. 270.5 over 28.6. That's about 84 degrees. 84.0, rounded to the nearest tenth. And that is in the, let's see, I have negative, positive, negative, positive. So that is in the second quadrant. If we're doing north, south, east, west style, that means I am north of west. North of west. I don't know why I made that dramatic W there. I didn't really mean to do that.